Analyzing a quadratic that's written in vertex form is in many ways even easier than analyzing a parabola that's written in standard form. Your key for seeing that you're written in vertex form is you'll have this set of parentheses usually with that squared outside of it and then adding a number at the end. If you don't see a number at the end, remember it's 0. The reason this is called vertex form is because the way it's written, we should be able to just pull the vertex right out of the form, right out of the equation. These two numbers, h and k, will represent the coordinates of the vertex. Keep in mind that that h value, we always have to do the opposite of what it says. So for this parabola down here, my vertex is going to be these two values to make up the vertex with the opposite of the first one. So my vertex is going to be located at -2, 5. Since the axis of symmetry is just a vertical line that passes right through the vertex, that's going to be x equals -2, so that those numbers always match up. And then let's see, domain. Well, in the other video we talked about how a parabola's domain is always going to be all reals, -infinity to +infinity, because there's no breaks in the parabola. It goes forever left and right in both directions, so we have all reals there. Now these last three, just like when we did standard form, I want to go ahead, at least I need to see what this graph looks like so that I can get a visual for what these are going to be. So let's go ahead at this point and then make a picture, make our graph using 5 points to do this. So let's start with getting our vertex plotted. So -2 and then 1, 2, 3, 4, 5. My vertex will be right there. I can draw on the axis of symmetry if I want to. That may help me find some other coordinates because I can use symmetry to do that. I'm also noticing too that this graph opens downward because I have a -a value. At this point, I think my best bet is I'm going to use a calculator to get a table of values set up. I don't really want to plug in a bunch of x and y values by hand, although I could. I don't really want to do that. So -2, 5 is my vertex. I'll put that in the center of the table. And then I'll pick a couple points above and a couple points below that. If you haven't done so yet, go ahead and, I guess, pause the video and type this in so you can take a look at the table. And you'll notice, though, that I probably don't want to pick like -3 as an x value because the y is a decimal. And even though, I mean, it's fine, I could graph it if I wanted to, nothing says I have to do that. And so maybe I want to pick only nice x values that get me nice y values. So for example, -4 gets me an output of +4. And then based on symmetry, 0 should also get me an output of 4, or you can check the table and see that that's true. If I look at an x value of -6 and check my table, I see 1 is an output. And then same down here with symmetry, 2 and 1 should be an output. So let's go ahead and get those points plotted. So 2, 1 would be right there. And again, I can just use some symmetry to eyeball where the other one is, or I can count 1, 2, 3, 4, 5, 6, up 1. Either way you want to do it, that's where that point's going to be. -4, 4 would be right here. Again, using symmetry, there better be a point right there, and sure enough, there is. 0, 4 was that point. So as nice of a smooth curve as you can, go ahead and connect those to make your parabola. You don't want to have any sharp points on this. You want everything nice and smooth. So there's a good-looking sketch or graph of this parabola. Now I should be able to answer these final 3 questions about my range and then where it's increasing or decreasing. Range is always going to be how low a parabola goes to how high it goes. Well, I can see that this parabola drops down forever. So the first part of my range is going to be -infinity. That's as low as this goes. It doesn't go up to +infinity, though. It does hit a maximum value. The highest this graph gets to is where the vertex is, the y value of 5. And since I can actually get to 5, it is a point on the graph. I use a square bracket to say that 5 is included. As far as where I'm decreasing and increasing them, these remember are x values. So I want to imagine I'm riding the roller coaster this way until I hit that wall. Well, as I go from left to right, I can see that the graph is increasing. I'd be climbing up that hill. So my graph is actually increasing from -infinity all the way until I get to that wall, which was at -2. Remember, we're using x values at this point. And increasing, decreasing always uses parentheses to describe intervals. Well, where my graph is going to be decreasing then is past that wall all the way on to infinity. I can see that's where the drop in this parabola is occurring. So from -2 to +infinity, this graph is going to be decreasing. Here's one more that I want to analyze and graph, and rather than talk all the way through this one, I think it'd be best if you guys pause the video, try it on your own. If you let it play through, my answers will pop up, but I'm not going to talk all the way through this one, so just a quick way to check to see if you've got the idea. So there's my vertex, +5 and -1. You can see I plotted it wrong. You'll see me fix it in a second. Oops, there we go. So to finish this one, there's my sketch. I've used my table on my calculator to find these points to get a look and see what this graph would look like. My range then was the lowest it got to was -1, and then it went upwards forever from there, so -1 to positive infinity. Notice the square bracket. And then finally my decreasing intervals, my parabola was decreasing as I went left to right until I hit that wall at 5. And remember, we're using x values again to describe intervals where I'm increasing and decreasing. And then my roller coaster is increasing from 5 all the way on to infinity. That roller coaster is climbing back upwards.